So in the last video, I was just saying about how one of the points, the fixed points we pick for Kelvin to start measuring our to use in our setting a temperature scale is absolute zero. That's our bottom one. Rather than picking water freezing and saying that's 0 degrees, we pick the lowest you can possibly go, the lowest temperature possible, and say that's 0 Kelvin. And that's one of the ones we pick, and we were talking about why that makes a lot of sense. The next one is there's not really another really fundamental thing for us to use that's completely aside from, because remember 0 Kelvin is 0 Kelvin for, well, it's for anything, but there's the lowest possible temperature anything could go, because at that point nothing is moving. That makes sense. But for the next thing, we kind of have to pick something that's just related to a particular substance, and so what scientists have done is pick the most scientific one they can, which is the triple point of water. So where Celsius uses 0 degrees for pure melting ice, and then 100 degrees for boiling of water, the steam point. This is what this is going on there. The absolute scale picks absolute 0 as its bottom, and then it picks the triple point of water as its next one. And from there you can divvy up the distances between that in certain amounts of Kelvin, and then you're good to go with your temperature scale. So the triple point of water is just the temperature at which ice, liquid water, and water vapor exist in thermodynamic equilibrium at 273.16 Kelvin. What does that mean? What does this thermodynamic equilibrium mean? All it means is that there's no net flow. Just as we were talking about up here, where we're talking about thermal equilibrium, it's basically the same thing. All we have is that this gas, there's no gas will, this steam, this water vapor will condense into water, which will then freeze into ice, but as that's happening, ice will be melting into water, which will be turning into water vapor, and so there's this no net transfer of anything. You have the water turning into vapor, vapor condensing into water, water freezing, ice melting, and we're in thermodynamic equilibrium. And we just decided that is 273.16 Kelvin. You might think that's a bit odd. The reason why that's been picked is to do something we're going to talk about in a second, which is to make Kelvin and Celsius as similar as possible. So before we get to that, we'll just talk a little bit more about absolute zero. So absolute zero is the lowest temperature any object can have. At this temperature, any object has minimum internal energy, regardless of what it's made out of. What does that mean? Well, it just means that at 0 degrees Kelvin, just what we're talking here, it just means no vibrations, no movement, nothing. The particles are just sitting. In fact, really, again, going back to this quantum thing, there's a whole lot more complicated stuff that goes on, but it doesn't matter whether you're water or iron or diamond or coal or anything. At 0 Kelvin, you are doing nothing. There's no internal energy because you have this kinetic energy. There's no vibrations. There's nothing you can do. 0 degrees means that you have no energy whatsoever apart from the your mass energy you're made out of and whatever light energy is going into your bonds, and you can't do any more.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.